Test. 1, 2, 3. Okay, hello guys. So it's been a while since I have streamed of me studying. Okay, so the reason is I haven't been streaming for like 12 days is because of my midterms. I finished my midterms now, and I'm going to go back and I'm going to finish off the paths again. And today we are going to continue with the GraphQL vulnerabilities, API vulnerabilities. And you'll probably notice that the workspace that I'm using is probably different than usually because I bought a new laptop, I bought a Mac, so I changed to Mac because a lot of reasons. And yeah, and because I'm using Mac, cherry tree, there's no cherry tree inside of Mac, like there's no like the official build for Mac, I think. So I'm going to change to take notes on Sublime Text. And because I can't use two monitors because I don't have the translator from USB-C to the HDMI because it's still coming. I bought it online but it haven't came, so it'll probably you guys will see me taking notes while I'll wait for that. Yeah. So let's start with GraphQL API vulnerabilities. Ooh. Okay. Finding GraphQL endpoints. Before you can test GraphQL API, you first need to find its endpoints, as GraphQL APIs use the same endpoint for all requests. This is a valuable piece of information, so we shall remember that. Okay. This section explains how to probe for GraphQL endpoints manually. However, Burp Scanner can automatically test for GraphQL endpoints as part of its scans. It raises a GraphQL endpoint found issue if any such endpoints are discovered. Okay. Should I put it on my notes? Yeah, I'll put it on my notes. Let me write it down manually. For our class, yeah. This is very interesting. Okay, universal queries. If you send query type name to any GraphQL endpoint, it will include the string data. Somewhere in its response. This is known as a universal query, and this is a useful tool in probing whether a URL corresponds to a GraphQL service. The query works because every GraphQL endpoint has a reserved field called type name that returns the queried object's type as string. So this is a way to it's bad. What's that? Huh? Okay. I don't understand what's wrong. Wait, let me universal queries. Let's paste the first one. Oh, okay. It automatically creates the red. So I think this is like the basics of GraphQL. This is like a built-in that is similar to SQL, that the schema, yeah, it's similar to that. So it is always used. Common endpoint names. GraphQL services often use similar endpoint suffixes. When testing for GraphQL endpoints, you should look to send universal queries to the following locations. Okay, If this common endpoints to return a GraphQL response, you could also try appending v1 to the path. GraphQL services will often respond to any ground GraphQL request with a query not present or similar error. We should bear this in mind when testing for GraphQL endpoints. So, as we want, GraphQL. Oh, I didn't know about that. What about versus v2? Oh, okay. So the point of trying to access v1 is only to get the GraphQL error, right? I thought the path meant like the v1 means GraphQL. Okay, next is the request method. And the next step in trying to find GraphQL endpoints is to test using different request methods. It is best practice for production GraphQL endpoints to only accept POST requests that have a content type of application JSON, as this helps to protect against CSRF vulnerabilities. However, some endpoints may accept alternative methods such as GET requests or POST requests that use the content type of your form URL encoded. If you can't find the GraphQL endpoint by sending POST requests to common endpoints, try sending the universal query using alternative HTTP methods. Okay, so it's basically just sending a REST API to every part of the wordless, I don't know, of the base, how can I say it? Base endpoints, yeah. Initial testing. Once you have discovered the endpoint, you can send some test requests to understand a little more about how it works. If the endpoint is powering a website, try exploring the web interface in the browser and use the HTTP history to examine the queries that are sent. Okay, let's continue. So now we are going straight to exploiting. Okay, exploiting unsanitized arguments. At this point, you can start to look for vulnerabilities. Okay, testing query arguments is a good place to start. If the API uses arguments to access objects directly, it may be vulnerable to access control vulnerabilities. A user could potentially access information that they should not have simply by supporting an argument that corresponds to that information, which is sometimes known as an insecure direct object reference IDOR. Okay, is it a lab? Okay, it's not a lab. Exploiting unsanitized arguments. Continue. Okay. For example, the query below requests a product list for an online shop. Okay, so the online shop will have a query that finds products which contains the ID, name, and where is it listed, or how. Oh yeah, is it listed, not where is it listed, my bad. So the product list return contains only listed products. So okay, this is the response, right? From this information, you can infer the following. Products are assigned a sequential ID. Product ID 3 is missing from the list, possibly because it has been delisted. Ooh, I didn't notice. Okay. By querying the ID of the missing product, we can get its details, even though it's not listed on the shop and was not returned by the original product query. What? That's very interesting, not gonna lie. I don't get how this works, so I think I'm gonna ask ChatGPT. I'm gonna use the free version because why not? Wait, I wanna see something again. Okay. Product is the field of the root query, argument being passed to that field. Inside are the fields you want back from the result. Oh. Are AI stupid or am I stupid? I don't understand. Maybe it's just a bit of guessing. Okay. Discovering schema information. The next step in testing the API is to piece together information about underlying schema. The best way to do this is to use introspection queries. Introspection is a built-in GraphQL function that enables you to query a server information about the schema. Introspection helps you to understand how you can interact with GraphQL API and can also discover potentially sensitive data such as description fields. Okay, interesting. Using introspection. To use introspection to discover schema information, query the schema field. This field is not available on the root type of all queries. Like regular queries, you can specify the fields and structure of the response you want to be returned when running an introspection query. For example, you might want the response to contain only the names of available mutations. Okay, so let's introspection queries GraphQL. Okay, so I'll put it on my notes. Let's copy this. Interesting. Let's continue. Okay, probing for introspection. It is best practice for introspection to be disabled in production environments, but this advice is not always followed. You can probe for introspection using the following simple query. If introspection is enabled, the response returns all the name of all available queries. They provide an example, so I'll put it inside. Why is it crooked? I'll just tap. Yeah, okay. Nice. Running a full introspection query. The next step is to run a full introspection query against the endpoint so that you can get as much as information on the underlying schema as possible. The example query below returns full details on all queries, mutations, subscriptions, types, and fragments. So, okay, so let's also save this. Okay. I think that's too long. But I can close it. Yeah. So if introspection is enabled but the above query doesn't run, try removing the onOperation, onFragment, and onField directives from the query structure. Many endpoints do not accept these directives as part of an introspection query, and you can often have more success with introspection by removing them. Okay, let's see. I wanna check them out. Which to delete? Is it this one? Let's read it again. On operation, on fragment, and on field. Yeah, it's the same, so I can remove 3 of this after needs to be deleted to run query. Okay. I'll keep that in mind so that we can use them. Okay, this is the same. Visualizing introspection results. Responses to introspection queries can be full of information but are often very long and hard to process. You can view relationships between schema entities more easily using GraphQL Visualizer. This is an online tool that takes results of an introspection query and produces a visual representation of the returned data, including the relationships between operations and types. Okay. Interesting. Suggestions. Even if introspections is entirely disabled, you can sometimes use suggestions to glean information on the API structure. Suggestions are a feature on the Apollo GraphQL platform in which the server can suggest query amendments in error message. These are generally used when a query is slightly incorrect but still recognizable. For example, there is no entry for product info. Did you mean product information instead? Oh, so it suggests. The error message is a suggestion. You can potentially glean useful information from this, as the response is effectively giving away valid parts of the schema. Ooh. Okay. Clairvoyance is a tool that uses suggestions to automatically recover all or part of a GraphQL schema. Even when introspection is disabled, this makes it significantly less time-consuming to piece together information from suggestion responses. You cannot disable suggestions directly in Apollo. Clairvoyance. Wait, what is that? Clairvoyance, GraphQL tool. I'll keep that. Suggestions. Accessing private GraphQL posts. The blog page for this lab contains a hidden blog post that has a secret password. To solve the lab, find the hidden blog post and enter the password. Okay, so let's open Birdsheet and open the challenge, I guess. Okay, so let's open the challenge. Okay, so let's read the challenge again. The blog page for this lab contains a hidden blog post that has a secret password to solve them. Okay, so let's try to solve it again. So there's a hidden post. I'm pretty sure. Why is it so ugly? I need to make it bigger. Is it because I'm in Mac, so the \n is ugly? So let's try sending. Wait, I wanna see this better. I don't think this is the back end of the. Okay, so it doesn't work like that. Can I use this again? So let's just try to access the schema. Okay, let's try it ourselves. We can enter schema query type. Oh, I thought they were using the normal. Get block summaries, operation name, get block. What if we remove all of these? Oh, never mind. This is the one that we used to see if it is using. Oh no, right? Wait, let's just go back. What if we use the one from before? Get blog posts and ask ID. Let's try getting 3. Does this work? Missing field argument ID. Is it here? Oh, okay. What if we copy? What is wrong? I don't understand. Let me just take all of the query. Let me change it to 1. 2, 6 or 7. Okay, so it's below 6 and 7. 6, 7. What about number 4? Am I cooked, chat? Am I cooked? Wait, let's check the website out. This is number 4. So let's... Okay, so we can preview the link. Oops. Preview link. Here's the link. Oh, I don't think that previews the link. What's this? 4. What number is this? 5, 4 and 5. 1. 2. This is the 1. Yeah, 3 is not provided, right? So I thought the secret post was at number 3, but I don't think it is. Okay, let's try to research. Let's try accessing this. Invalid JSON. So, oh, it contains post password. Okay, so let's try accessing this part because looks interesting. Just put it here, maybe. So it's below. Is this the password? Let's try accessing the Chromium. Wait, where can I submit the password to? Oh, okay. Oh, nice. Okay, so the challenge is about enumerating. So yeah, I'll save this query. I'll put it at enumeration. And also, I think I'm gonna put it in a code block. And also put the hack tricks link there. Nice. So yeah, that was pretty cool. And let's continue. Nice. So let's refresh to see this solved. Okay. So let's check the solution so we can study. Okay. Yeah, I noticed that the number 3 is missing. Yeah, it was missing. Nice, that's very interesting. Accidental exposure of private GraphQL fields. The user management function for this lab is powered by a GraphQL endpoint. The lab contains an access control vulnerability whereby you can induce the API to reveal user credential fields. Okay. Do we have winner Peter? Oh, okay, we don't have any accounts. But what if I press my account? What if I try to log in? Ooh. Interesting. So let's send this straight to the repeater and create a different repeater also to enumerate. So let's try the payload from before, the query, and let's try to send it first. Okay. So let's try deleting this and sending the query. Okay, so it still leaked the query. Let's try accessing the user. To be honest, I don't understand on how can we access the user variables. Wait. Okay, so Let's try removing this part. Is it like this? So let's try to get their ID and username first. I don't understand how to request. What if we query get user with a big view? Hmm. Oh, there is a built-in introspection query. I didn't. Oh, I thought GraphQL was only provided to Burpsuit Pro. Never mind. Oh, so that's how we can solve the challenge. Okay, so I didn't know Burp Community Edition have a built-in GraphQL function that we can use and set the introspection queries automatically, and then just make the Burpsuit request all of the GraphQL queries to the sitemap so we can use them. Okay, so I didn't know about that, and that is very interesting for me, and I learned something new. Okay, that's very cool, can't lie. Okay, let's continue. Bypassing GraphQL introspection defenses. If you cannot get introspection queries to run for the API you are testing, try inserting a special character after the schema word. When developers disable introspection, they could use a regex to exclude the schema keyword. In queries, you should create characters like spaces, new lines, and commas, as they are ignored by the GraphQL but not by float regex. As such, if the developer has only excluded schema, then below the introspection query will not be excluded. Okay, wait for new line. Interesting. The example below shows an introspection probe sent via GET with a URL encoded parameters. Okay, so this is a lab. The user management functions for this lab are overpowered by a hidden GraphQL endpoint. You won't be able to find this endpoint by simply clicking all the pages in the site. The endpoint also have some defenses against introspection. To solve the lab, find the hidden endpoint and delete Carlos. Okay, interesting. So do we need to find the basic endpoints? Yeah, let's try to access the basic endpoints, and hopefully we can find one of them. Not found. .php console API. This is taking so much time to load. Only to load. It's already taking a lot of time. API. It's taking a while to load. I'm pretty annoyed. Oh, query not present. So I actually found the API, probably. So let's clear the HTTP story first, and then can try getting the API. And, let's give it a schema. Wait, why is it not copied? Wait, I forgot to send it to repeater. That's pretty stupid of me. Query not present. So where's the content type? Content type. Why is it invalid? So we can only use get. So I'm gonna ask my AI again, sadly, because I feel like nothing's wrong. What's wrong with my JSON? Oh, okay, I was very stupid. It's not inside of a body. Why didn't I notice that? Introspection is not allowed. Okay, so we can use the bypass. We can bypass the filter by giving an enter. So interesting. So then let's see the challenge and delete the user Carlos. Okay, so we can first try and use the GraphQL and okay, so let's delete all of this because it's useless. Can I delete it? Delete selected items, yes. I want to delete all of them. Then hopefully this works. Please. It doesn't. Schema. So let's enter. And then GraphQL sitemap. Get user and delete. Okay, so let's first try to find the Carlos. Okay, so let's use this and send it to the repeater. Get user. What about number 1? 1 is the administrator, right? So it's probably the ID is 2. Oh no, okay, it's 3rd. So we shall delete the 3rd user. Let's try and delete Carlos. Is this delete? Did we solve the challenge? Let's remove the API. Nice, we solved the challenge. Yeah, that was very fun. Okay, let's refresh and check out the solve. Nice. Let's check out the solution first so we can understand. Maybe we did something wrong. What? Oh, because we are using the browser, we can give it a parameter. Yeah, query. Didn't thought about that, but can give it in JSON data as well. Oh, we can also give it a URL encoded. Yeah, it's basically the same as what I did. And yeah, that's very fun. Nice. So let's continue. Hello. Oh, okay. So this time we are bypassing rate limiting using aliases. Ordinarily, GraphQL objects can contain multiple properties with the same name. Aliases enable you to bypass this restriction by explicitly naming the properties you want the API to return. You can use aliases to return multiple instances of the same type of object in one request. While aliases are intended to limit the number of API calls you need to make, they can also be used to brute force a GraphQL endpoint. Many endpoints will have some sort of rate limiter in place to prevent brute force attacks. Some rate limiters work based on the number of HTTP requests received rather than the number of operations performed on the same endpoint. Because aliases effectively enable you to send multiple queries in a single HTTP message, they can bypass this restriction. Ooh. Okay, I wanna save this because sounds very interesting. Okay, so let's find it on Google. GraphQL aliases. Oh. Oh, okay. Excuse me. By passing rate limiting using aliases. The simplified example below shows a series of alias queries checking whether store discount codes are valid. This operation could potentially bypass the rate limiting as it is a single HTTP request, even though it could potentially be used to check a vast number of discount codes at once. Oh, this is the aliases. Okay. I didn't notice. I thought this was the alias. So I was wrong. Okay. So let me save that for reference. Wait, what? Okay. Wait, oops. Okay. Can continue now. By passing GraphQL brute force protections. The user login mechanism for this lab is powered by GraphQL API. The API endpoint has a rate limiter that returns an error if it receives too many requests from the same origin in a short space of time. Use the list of authentication passwords as your password source. Okay, so this is very helpful. Yeah, I thought about it because this requires us to create such a big word list. But thankfully, they provided us with this. So let's try. Okay, I'm gonna put this inside of here, cause yeah. So the way we are going to solve this lab, wait, I forgot to take the the URL. Okay, the way we are going to solve this lab is by first taking this and opening our burp. Let's solve it. Ha. And try to log in to which person again? Carlos, right? Sign in as Carlos. Okay. I feel bad for Carlos because we are always targeting Carlos. Not gonna lie. Okay. Let's clear our history. Carlos Montoya. Okay, so put this to the repeater and possibly I don't think this would work, not gonna lie. Did I put it inside of variables? I don't think so. Yeah, it hasn't found JSON. I don't understand how can we use it. Really? Mutation? Oh yeah, it's inside of a mutation. So it's possible to do this then. Mutation. Can I just use this? Some file JSON. What if you just find and replace? Could this work? Then we can provide a mutation. What's wrong though? Oh wait, don't you say I copied all of the so let's copy it then. Invalid JSON? I don't understand why it's invalid. Am I cooked, chat? I'm gonna ask ChatGPT to create the payload because I have no idea. Let's create it again. Low pasting. So let's try to use find and replace again. Yeah, I forgot about this backslash. Please tell me this works. Oh, it works now. Okay, so the only problem I was doing is because I was using a different kind of, what is it called again? the quotation marks. Yeah, I was using the different kind of quotation marks, and I was a bit confused on how to use the right quotation marks, but I didn't thought about the backslash. Yeah, that was a beginner mistake, so it's my bad. So let's try to find the true one though. So this is the token, so let's try to log in to Carlos. Okay, I need to try again 1 minute. Wait, which one is true? Oh, I don't think that is the password. Yeah, we need to find the number 75 here. Oh yeah, this is the password. So I need to wait a minute. Yeah. Please. Speed. I need this. Speed. Yeah, by the way. We already solved the challenge. Yeah, I kinda cheated because I looked at the hint, right? What? Are we serious now? 70. Oh, that's 71. Oh, Joshua. The password is Joshua. Bro, what am I doing? Okay, now we have solved the challenge. You can refresh it again. Nice, solved. Okay, so now we are going to learn about CSRF on GraphQL. GraphQL CSRF. Cross-site request forgery. Vulnerabilities enable an attacker to induce users to perform actions that they do not intend to perform. This is done by creating a malicious website that forges a cross-domain request to the vulnerable application. GraphQL can be used as a vector for CSRF attacks, whereby an attacker creates an exploit that causes a victim's browser to send malicious query as a victim user. How do CSRF over GraphQL vulnerabilities arise? CSRF vulnerabilities can arise where a GraphQL endpoint does not validate the content type of the request sent to it, and no CSRF tokens are implemented. Post requests that use the content type of application.json are secure against forgery as long as the content type is validated. In this case, an attacker will be able to make the victim's browser send this request even if the victim were to visit a malicious site. However, alternatively, methods such as GET or any request that has content type xwww form URL encoded can be sent by a browser, and so may leave users vulnerable to attack if the endpoint accepts this request. Where this is the case, attackers may be able to craft exploit to send malicious requests to the API. Attackers may be able to craft exploit to send malicious. Oh. The user management functions for this lab are powered by GraphQL endpoint. The endpoint accepts requests with a content type xwww form URL encoded and is therefore vulnerable to cross-site request forgery attacks. To solve the lab, craft some HTML that uses a CSRF attack to change the viewer's email address, then upload it to your exploit server. You can log into your own account using the following credentials. Okay. So I think I'm going to view the solution because I don't have my notes here. So to be honest, I completely forgot on how can I use CSRF. I need to relearn everything again. These 12 days are very, very bad. We are provided with the winner, Peter, right? Yeah, as usual. Can you please just load, please? Please just load. I'm tired. It's taking so long to load. 10 years ago. Okay. Winner Peter. So .NET email, right? To be honest, I forgot on how to create a CSRF. But let's try to solve it first, okay? Can try to find it at Google, GraphQL, CSRF, attack, and possibly payload. I feel like this is the... I know this is going to show me a write-up for the portswigger. Oh, never mind, it's different actually. So let's try to take that. Let's put it first to read what. Okay, so we can input. Okay. So the action is to access the host GraphQL. So let's change all of the init into our URL. Then let's check the mutation, change email input, change email input. So this is basically, isn't this the write-up? He just took this portswigger and turned it into something that doesn't seem to be from the portswigger, but it is from portswigger. I'm sure of it. Yeah, it works. I can deliver the exploit to the victim. But it's not solved. But it works though. Oh, I think it is because of our same email. Because I already used the email. We can change to the same email, right? Wait, let me try. Let me try. A at a dot a. Can I change to the same email? Okay, so the email. Yeah. I can only change to a unique email. Yeah, but it works. So let's hear the solution. CSR furniture. So I'm going to copy this and put it in my notes. Don't save this one. CSRF. Wait. I need to put it in a code block. Make it to HTML. Nice. Let's continue. It's solved. Nice, let's continue. Now we are going to learn about preventing GraphQL attacks. So this is the part where I love to take my notes, because this is the part where we can explain on how to prevent GraphQL attacks. So if in the future we find a CSRF vulnerability, or never mind, if in the future we find a GraphQL attack vulnerability, like a GraphQL vulnerability in a website or in a bug bounty page or domain, we can explain to them on how to fix it and how to prevent more GraphQL attacks. Yeah, it's pretty neat, cool, pretty neat. So yeah, preventing GraphQL attacks. To prevent many common GraphQL attacks, take the following steps when you deploy your API to production. If your API is not intended for use by the general public, disable introspection on it. This makes it harder for an attacker to gain information about how the API works and reduces the risk of unwanted information disclosure. For information on how to disable introspection in the Apollo GraphQL platform, see this blog post. Where's the blog post? Boom. I think I think they forgot to place the blog post. It's really funny. Okay, if your API is intended for use by the general public, then you will likely need to leave the introspection enabled. However, you should review the API schema to make sure that it doesn't expose unintended fields to the public. Make sure that suggestions are disabled. This prevents attacker from being able to use clairvoyance or similar tools to glean information about the underlying schema. You cannot disable suggestions directly in Apollo. See this GitHub thread for a work. Okay, so they forgot to upload the GitHub thread also. Make sure that your API schema does not expose any private user fields such as email addresses or user IDs. Okay, let me save this to my notes. Notes. And continue. Preventing GraphQL brute force attacks. It is sometimes possible to bypass standard rate limiting when using GraphQL APIs. For example, see the bypassing rate limiting using a list. Okay, this is telling us to fill the section again. Yeah, from before, the one where we use our console with the provided code from the challenge to create the word list. And we need to put and then sign a mutation, the one that I closed before. Yeah. With this in mind, there are design steps that you can take to defend your API against brute force attacks. This generally involves restricting the complexity of queries accepted by the API and reducing the opportunity for attackers to execute a denial of service attacks, those attacks. Okay, so we can limit the complexity of the query, maybe by length or maybe by something, I don't know. Configure the operation limits. Operation limits enable you to configure the maximum of unique fields, aliases, or root fields that your API can accept. Configure the maximum amount of bytes a query can obtain. Yeah, this is what I said, right? The length, maybe the bytes, maybe the how many lines. Yeah, I don't think lines could count. Maybe how many, yeah, bytes, how many characters. Yeah, it's the same. Consider implementing cost analysis on your API. Cost analysis is a process whereby a library application identifies the resource costs associated with running queries as they are received. If a query will be too computationally complex to run, the API drops it. Okay, so let's save it. Oops. Wait, what? So let's continue. Preventing CSRF over GraphQL. To defend against GraphQL CSRF vulnerability specifically, make sure of the following when designing your API. Your API only accepts queries over JSON encoded posts. The API validates that content provided matches the supplied content type. The API has a secure CSRF token mechanism. So basically we can implement a secure CSRF, maybe by using a CSRF token or something, so that it doesn't happen. So are we finished? Let's see. Yeah, we are done with the GraphQL vulnerabilities. So thank you guys for watching. If you have watched, I hope you guys have a great day. And yeah, that was very fun. I learned a lot of new stuff like the CSRF function in the Birdseed. Yeah, that's pretty cool. And we learned a lot of things, a lot of new things. And we also learned the coolest part is chaining CSRF with the GraphQL. Yeah, I didn't know CSRF could use the mutations from GraphQL, or maybe I should call it the queries from GraphQL, to exploit and possibly getting new stuff. And yeah, it's very cool. Even the brute force one, the bypassing the rate limiting, it was very cool. I didn't know it could work like that. And I'm pretty sure the rate limiting, if we can bypass the rate limit, I'm pretty sure we can do something like DOS. There are similar cases like the SQL pull technique to do a DOS attack. I think it could work with the GraphQL. It's probably similar. Yeah, that was very fun. And yeah, we have finished today. I don't know what I'm going to do. Like, I'm not sure if I'm going to create. I'm not sure if I'm going to stream tomorrow. Probably in couple of days I'm gonna stream again. So I have web cache deception, protect pollution, 2, 3 risk injection, and 4 risk injection. I only have 4 left. Ooh. What? 4 left? 1, 2, 3, 6, 9, 12. Oh no, I also have CSRF. I haven't did the CSRF part because it sounds annoying. Yeah, but yeah. I hope you guys enjoyed my video. Thank you. I'm going to end the stream now. See ya.